Welcome to qnawire.
All right. So in this problem, we have the network. So we have five capacitors. So this is C1, C2, C3, C4, and C5. Okay. And we know the value of C1 equals C5. This equal 8.4 microfarads. And the C2 equals C3 equals C4 equal 4.2 microfarads. Okay. And we also know that the voltage across AB is 220 volts. So in part A, I want to find out the equivalent capacitance for the network. So basically, you can see that the C3, C4 they're in series. So in that case, C3, 4 equal half C3 because C3 equals C4, right? So this gives you 2.1 microfarads. And C2 is in parallel with C34, so C234 equals C2 plus C34, right? So this gives you 6.3 microfarads. And then C2 is in series with this is C1. And then C1 is in series with C5 and the C234, right? So the total equivalent capacitance of this net connection is 1 over C equal 1 over C1 plus 1 over C5 plus 1 over C234, right? And you can obtain that the C equal 2.52 microfarads, all right? And in part B, you want to find out the charge stored on each capacitor and the voltage across them. So if you look at this connection, you see that since we already have the total capacitance, which is over here, so the charge, the total charge stored on the system will be equal to the charge stored on C1, C5, right? So let's firstly see what is the total charge. So Q, the total charge equal, actually equal Q1 and also equal Q5, right? So this equal C times V. So C is the total equivalent capacitance, and V is the voltage. So this gives you 554.4 microcoulombs. All right. So you can obtain that V1 equal V5 equal Q1 divided by C1. It also equal Q5 divided by C5, right? So you can see that this equals 66 volts. And for Q234, as you can see that 3, 4, they're in parallel with 2. So in that case, we have expression Q2 equal Q, which is the total charge, times so C2 divided by C2 plus C34, all right? So you can see that this gives you 369.6 microcoulombs, and Q3 equal Q4 because Q3, Q4 they are in series, so they have the same charge. So this equal Q times C34 divided by C2 plus C34, and this gives you 84.8 microcoulombs, all right? So that you can obtain that the V2 equal Q2 divided by C2. So this gives you 88 volts. And the C3, sorry, not C3, V3 equal V4 equal Q3 over C3, right? So this gives you 44 volts, okay? So we already figured out all the charges stored on the capacitors and the voltages across them.